So this is, we're going to say this is section, chapter 5.1, 5.2. Perimeter and area review, and these are just, your formulas are just going to go into the flip book. So we're just going to talk, just going to have a quick, kind of a quick reminder about our formulas and how they work. So the first set of shapes there on the first page is under quadrilaterals. And the first one we're going to talk about are squares, rectangles, and parallelograms. So perimeter. How do we find the perimeter of any shape? Add what? Add all the sides. So we just, no matter what shape it is, if we just add up all the sides. So there's not really a formula. It just we need to remember to find our perimeter. We just add all the sides. Now, when we get to circles, some other more complicated shapes, we will have a formula. But the basic idea is we're just adding up how far it is around is what we're talking about with perimeter. And our area formula. Let me draw a rectangle to match your flip book. So for a rectangle or for a square, for a nice shape like this, what is our area formula for one of these? Multiply the two sides. And what do we, so we're multiplying two sides, what do we normally like to call our sides of our rectangle? Base times height, we could say base and height. So if you want to label your picture. So area is going to be base times height. What was another one? What did you say, Lindsay? Length and width. We could call it length times width. Base times height, length times width, they mean the same thing. And the way we normally write it, if we just use symbols B times H or L times W. So base times height, length times width. It turns out that for parallelograms, it's the same formula. So let me draw a parallelogram here to go with the one that's in your flip book. So for a parallelogram, we can think of it the same way, but if this is the base, the only difference with a parallelogram is our height has to go at a 90-degree angle to the base. So that's what that line drawn in there is. This is going to be the height of my parallelogram. So I use the same formula. Base times height. You can think of length times width for a parallelogram. We usually call it base times height. One important thing to remember with a parallelogram is I can find the height outside the parallelogram. So this little red dotted line is going to be the height also. So the height doesn't necessarily have to be inside the parallelogram, as long as it makes a 90-degree angle with the line that comes from the base. But it's the same formula, length times width, base times height, same idea. And the formula works out that way because with a parallelogram I can always cut this triangle off the side here, move it over to this side, and I turn the parallelogram into a rectangle. So it's the same formula. So those are our formulas for squares, rectangles, and parallelograms. Perimeter, we add up all the sides. The area, base times height, length times width. For a parallelogram, the height has to be make a 90-degree angle with the base. Questions on those formulas? All right, let's look at a trapezoid. Trapezoid, not much different. Same idea as with a rectangle or a parallelogram. So let's draw our trapezoid here to match the one in your flip book, and then we'll label the parts and we'll talk about the formula. So there's my trapezoid. Remember that a trapezoid has two bases. So I'm going to call this one base 1 and this one base 2. And I'm going to put this in here, draw this in. The height, we find the height at a 90-degree angle between the two bases. So our formulas. How do we find the perimeter? Add up all the sides. So there's not really a formula, we just add up all the sides. And again, that works for any shape, add up all the sides. Our area. Anybody remember the area formula for a trapezoid? Base 1, almost, base 1 plus base 2. And I'm going to put that in parentheses. Times the height. And I'll write it all out. Times height. All divided by 2. And the way we usually write that is B1 plus B2 times H divided by 2. And another way we could say it means the same thing, is 1/2 B1 plus B2 times H. 1/2 is the same as dividing by 2. So all of these mean the same thing. So we add the two bases, multiply by the height, and divide by 2. So it's like the formula for a rectangle or a square or a parallelogram. We just have to have these two bases. We take these two bases into consideration. Does anybody remember what other thing we got by adding the two bases and dividing by 2 for a trapezoid? That was how we found the mid-segment. So we can also think of this as the length of the mid-segment times the height. So just a little side note. So same idea. Perimeter, we add up all the sides. The area, add the two bases, multiply by the height, divide by 2. And the reason this formula works out the way it does is that I can always take two trapezoids and put them together to make a rectangle. So if I put two trapezoids together, a parallelogram. If I put two trapezoids together, I get a parallelogram. So I end up adding the two areas, and that's why we end up dividing by 2. Because I can always put two trapezoids together to get a parallelogram. So that's why the formula works out that way. Questions on that one? Okay, our last one that we're going to talk about today, not what I wanted to do. Our last review formula is triangles for triangles. So our perimeter. How do we find the perimeter? Add all the sides. That's all we ever have to do. The area. What's the area formula for a triangle? Base times height divided by 2. And we also write BH divided by 2, and that's the same as saying 1/2 base times height. 1/2 and divide by 2 mean the same thing. So let's draw our picture. We can label our parts here. Grab a triangle. So there's our triangle. The height, we find the height at a 90-degree angle to the base. This side's the base. Any side of the triangle can be the base. It doesn't have to be the one that's down at the bottom of our picture. Any side can be the base. Our height just has to make a 90-degree angle with the base and go to the opposite vertex. So any side can be a base. The height makes a 90-degree angle with the base. Another word that we use for height, for triangles, for trapezoids is altitude. So height and altitude, we usually use them kind of to mean the same thing. And like parallelograms and trapezoids also, the height doesn't have to be inside. So if I have a triangle that looks like this, I would find the height here by going out from this base, like so. So for this triangle, that would be the height. So we don't have to find the height inside the triangle. It can be outside the triangle. So if my triangle look like this one, we find the height outside the triangle. But our formula is just base times height divided by 2. Questions on that one? Okay, what I want to do, those are our review formulas. So let's look at problem number 1.
This is our homework, right?
Yes, and we're doing the odds, and I'm going to do 4 or 5 of them right now, so you have some of your homework problems done. So we're looking at number 1. On most of these, they don't give you a picture. It can help you a lot to draw a picture. So number 1 says the base of a rectangle. So I'm going to draw a little rectangle. Doesn't have to be beautiful, doesn't have to be perfect, doesn't even have to be that big, just a little sketch. The base of a rectangle is 24.3 centimeters. And the area is 580.77 centimeters squared. And it wants us to find the height. So we're not just plugging our numbers into our formula, we have to do a little more work. So we know when you have a problem where they give you parts of the formula and you need to figure out the other parts, plug in what you know to your formula and solve for the part that you don't know. So how do we find the area of a rectangle? What's our formula? Base times height. So my area is 580.77, and that equals the base, 24.3, times the height. And now from here, how do I find the height? Divide. I need to get h by itself, so I divide by 24.3. And if I plug that into my calculator, 580.23.9. So the height comes out to be 23.9. Now in Chapter 5 and in Chapter 6 and 7, when we're talking about areas and volumes, I'm going to be picky about the units. So area is in units squared. Length is in straight units. So the height is a length, and it gives us everything in centimeters. So my height comes out to be 23.9 centimeters. The units are important because centimeters is different than square centimeters. And when we start talking about volume, centimeters, square centimeters, and cubic centimeters are different things. So we have to make sure that we put our units in here. So that's one type of problem you might have to do, where you have to find one part of a formula where they give you other parts. Let's look at number 5. So number 5 is one that's going to involve some algebra. Or actually, number 5 is not too bad. It actually doesn't involve algebra. It says the height of a rectangle, so there's my rectangle, is 9 3/4 meters. And the base is 5 3/5 meters. And it wants to know the perimeter. Well, if this is a rectangle, and this side is 5 3/5 meters, what is this side? It's the same, right? Opposite sides are the same. And if this side is 9 3/4 meters, what big is this side? 9 3/4 meters. To find the perimeter, what do I do? Add them all up. Well, I can work with these fractions. What I would recommend doing is turning these fractions into decimals. So 9 3/4, I would say 3 divided by 4 is 0.75. So I turn this into 9.75 meters. And 3/5, I do 3 divided by 5, and I get 0.6. So this is 5.6 meters. And then I just add up all the sides. And my units are going to end up in meters. This perimeter is a length. So convert these to decimals, add them all up, and I get my answer in meters. Yeah?
What is if you do 9, I think it's divided by 3 times 3, or it's 2 there's like this.
Oh, it would be 9 times 4 plus 3. All that divided by 4. So if I turn this from a mixed fraction into a regular fraction, I would do 9 times 4 plus 3. 9 times 4 is 36. 36 plus 3 is 39. So this would be the same as 39 fourths. 9 3/4 is the same as 39. Okay, but you could do it that way. That would work also. All right, so that was number 5. Let's look at number 17. Number 17 asks us to plot some points. Oh wait, before we do number 17, let's do number 7. So number 7. Number 7 is one that involves some algebra. So number 7 says the perimeter of a rectangle is 40 meters. So there's my rectangle. And the perimeter, I'm going to say P is 40 meters. The base is 4 less than 5 times the height. So 5x minus 4. So if we say the height, let's say the height is x, we don't know the height. The base is 4 less than 5 times. So 5 times the height is 5x. 4 less than that is minus 4. So the height is x, we don't know what it is. The base is 4 less than 5 times 5. And it tells us the perimeter is 40 meters. Well, if this side is x, this side is also x. If this side is 5x minus 4, that side's 5x minus 4. And the perimeter, how do we find the perimeter? Add up all the sides. So x plus x, that gets me those two, plus 5x minus 4, plus 5x minus 4, and that equals the perimeter, 40. And I'm trying to find x. Add all the x's together, I get 12x. Minus 4 is minus 8. I get 40. Add 8 to both sides. 12x equals 48. Divide by 12, and x equals 4. The height is 4, and our units here are meters. So the height is going to be 4 meters. So on some of these we might have to, we'll have to set up some algebra like we did here. It says the base was 4 less than 5 times. 5x minus 4. Questions on that one? All right, let's look at number 17. Number 17 gives us some points. When we have points, what we're going to do is graph those points. Your graph doesn't have to be perfect and beautiful. Just sketch a quick graph. And we're going to plot the points. So number 17 gives us a parallelogram. The vertices are 2, negative 2, so I'm going to go over 2 and down 2. The next one is negative 2 and up 3. The next one is negative 2, down 2. And the next one is over 2 and up. And it says we want the area of this thing. Well, this one turns out to be nice. It tells us it's a parallelogram. To find the base and the height, all I have to do is count spaces. So how far is it from here to here? I'm just going to count. 1, 2, 3, 4, 5. So that side's 5. How far is it from here to here? 1, 2, 3, 4. This one goes from negative 2 to positive 3. This one goes from negative 2 to positive 2. So one side is 4, the other side is 5. So the area is going to be what? 4 times 5. Or 20. And it doesn't give us units here. It's asking us for an area. So I'm going to say 20 units squared. So when they give you the vertices, when they give you points, just plot the points, sketch out your figure, and count squares to find the base and the height. Just count your spaces to find your base and your height. So there are a few of those that you have to do. Questions on that one? All right, let's look at the other side. So flip over your paper and we'll do one more together. So on the other side, on the right-hand side, let's look at number 11. Number 11 says, actually, I don't want to do number 11, I want to do number 9. Let's look at number 9. It says the area of a rectangle. So there's my rectangle, my quick sketch. The area is 192 square millimeters. The base is 2 more than 5 times the height. So let's call the height x. How are we going to write 2 more than 5 times the height? 2 more than 5 times. So 5 times the height is 5x. And it's 2 more than that, so plus 2. So the base is 5x plus 2. The area is 192. How do we find the area of a rectangle? base times height, length times width. So my area is going to be x times 5x plus 2, and that equals what they gave us for the area. Now I have this parentheses here. First thing I have to do is distribute. X times 5x is 5x squared. X times 2 is 2x. And that equals 192. Now we did some of these last semester. And we have an x squared and an x and a number. What do we have to do? But it involves the exponents, but there's a particular thing we have to do to solve this kind of equation. We have to get everything on one side and 0 on the other. So I'm going to subtract 192 from both sides. I get 5x squared plus 2x minus 192 equals 0. When I have an equation with an x squared, an x, and a number, I either have to factor, which means I have to set up my parentheses, and that's going to be equal to 0, or I'm going to use the quadratic formula. This one, because of the 5x squared and the 192, this one I think is going to be complicated to factor. So I would use the quadratic formula for this one. On the back of the flip book, or in the margin of your flip book, you might want to write this down because it's going to come up a fair amount this semester. The quadratic formula. When we have an equation, ax squared plus bx plus c equals 0. X equals negative b plus or minus the square root of b squared minus 4 times a times c, and everything divided by 2a. So for this particular problem, and there are a couple like this on your homework, this is going to be a, this is going to be b, and this is going to be c. You would plug those numbers into the formula, and that would tell you x, and that would tell you that side of the rectangle, and your answer would be in millimeters. So anytime you have an x squared, an x, and a number, you either have to factor. First you have to get everything on one side and the 0 on the other. Then you either have to factor or use a quadratic formula. And there are a couple of those on the homework where you have to solve the problem. So that was 5. I did 5 of your homework problems. Five different types of problems that you're going to see on the homework. So you have about 10 minutes to work. We're working on the odds on the worksheet.
Both sides?
Both sides, yeah.
Oh.
But we just did 5 of them. So that's almost a quarter of them that we did. And some of them are really easy. It says like the base of a rectangle is this and the height is this. What's the area? So some of those are really easy.